Okay, so next we're going to do derivatives test part 2. Domain, we need to know domain by now. If you don't, please come see me. But in this question, the domain, we set that denominator and set it not equal to 0. So we get x squared minus 9 can't be 0. That gives me x squared can't be 9. Take the square root of both sides. We get x cannot be positive or negative 3. That's an acceptable answer. You could have also said negative infinity to negative 3, union negative 3 to positive 3, union positive 3 to infinity, all with parentheses because it can't equal positive or negative 3. Odd and even, we do need to remember. Odd is basically when you plug in negative x and you get the negative answer back, that's odd. The way you can remember that is x cubed. If you plug in negative x and you cube it, you get back negative x cubed. So that was the original. We plug in negative, we get a negative. F of negative x, if it comes back just as the positive answer, that's even. And you can kind of remember that with x squared is an even function. If you plug in negative x squared, it just comes back as x squared, which was the original. So in this case, we're going to plug in f of negative x into 2 divided by negative x squared minus 9. That gives us 2 divided by x squared minus 9, which is the same as that original function, right? So because f of x is equal to negative x, our function is even. Okay, part C. I'm going to do a quotient rule here. You could have rewritten this as 2 times x squared minus 9 to the negative first power, but quotient rule I think is going to be easier here. So f prime of x low is x squared minus 9. D high, derivative of 2 is 0 because it's a constant, minus high, derivative of the bottom, d low is 2x, all divided by x squared minus 9, all squared, which we can rewrite that's negative 4x divided by x squared minus 9, all squared. Alright, then the last part says to find the slope of the line normal. That word normal is a key word here. So first we have to find the slope of the tangent line, and then the normal will be perpendicular to that. So we already did find the derivative, so then we just, at x equals 4, we'll plug that in. So f prime of 4 will be negative 4 times 4 divided by 4 squared minus 9 all squared. Negative 4 times 4 is negative 16. Divided by 4 squared is 16 minus 9 is 7. 7 squared is 49. That's the slope of the tangent line, or that's just f prime of 4. To get the normal line, we need to do the perpendicular slope of that, which will be opposite reciprocal, so 49 divided by 16, and it's positive because it was negative before. Alright, moving on to part 2, or question 2. We have to remember here that when we see velocity or you see speed, that speed is equal to the change in distance divided by time. So if we see average velocity, that's basically asking me what is the average rate of change of the distance, right? Because velocity is just distance over time. So this would be s of 5 minus s of 2 divided by 5 minus 2. Now since this was a calculator question, you can just write s of 5 minus s of 2, and you are allowed to type that into your calculator. So you don't have to show your work because it is a calculator question. You do need to write that you're doing s of 5. So you just type that into your calculator. And again, if you do not write s of 5, the AP won't give you points. You have to write that that's what you typed into your calculator. You get 13 minus, then you plug in 2, and we'll get negative 5 divided by 5 minus 2 is 3, which will be 18 divided by 3, and it's a velocity, so my units are millimeters per second. Right, if you come back up here, the distance over time is in millimeters, and the units for time, distance divided by second, so millimeters per second. Okay, and you could have, 18 divided by 3, you could have just changed that to be 6. Okay, part B says how quickly. This was an AP question, so these are some vocab words we're going to have to start learning. But if it's asking you how quick something's moving, that's also asking about its velocity or its speed, right? So how quickly is really talking about what is its speed. And we'll talk about the difference between those two later on. And then at time equals 3. So now it's just at one time. So it's not an average anymore. Now it's at that time. So we have to know that the speed is the derivative of the distance or the position. Okay, so speed is our derivative of our distance. So we take s prime of t, and that will be 3t squared minus 12t plus 9. And then we're going to plug in 3, and we get 3 times 3 squared minus 12 times 3 plus 9. That gives us 3. And again, you could do this on your calculator. So, and you type that into your calculator and you get 0. Units are still millimeters per second. And it said, what direction is it moving? Well, to know this, you have to kind of go back to the problem, and it says that this is away from the origin. So your options are away from the origin, towards the origin, or just not moving. Well, if it has a speed of 0, it would just be not moving, or you could say like at rest, something like that. Okay, then it says when is the particle at rest? Well, we know it's at rest at 3, because that's when it was 0. But there might be other times. So when it says when is at rest, that's when is the speed equals 0. So we're going to take s prime of t and set that equal to 0. So that's 3t squared minus 12t plus 9 equal to 0. I can factor out a 3. T squared minus 4t plus 3 equals 0. Then we'll factor this. That's t minus 3 times t minus 1 equals 0. And then I set these each equal to 0. So I get time equals 3 seconds and time equals 1 second. Make sure that you put in the units. So there's that problem. To be honest, on the retake, I'm probably not going to put one with speed, velocity. I want to talk about that like more on its own later. So it'll probably be more like questions that are similar to number 1 here.